We're talking about the derivatives of inverse functions today, and what you might remember about inverse functions is that to find the inverse of a function, we can graph the function, and we reflect that function over the line y equals x, and that gives us the inverse. In fact, in like Algebra 1 and Algebra 2, when we talk about inverse functions, a lot of times we take actual wax paper and we draw the function, and then we fold that that drawing over the line y equals x to reflect it, because sometimes it's really hard to see what that reflection actually even looks like. So that's one way to think about it if you're having trouble picturing them. The other thing we know about inverse functions is that basically we just switch the x and the y values of all of our points. So if you had a table of values, you could just switch all the x's and y's, and you would have the inverse function. But a lot of times we really just have the function. That's usually the way we see inverses. And so to do that, we just switch the x and y and solve for y. Remember, we've been doing this a little bit here in calculus. So we're just going to switch the x and y and solve for y. So the first thing we're going to do here on example number 1 is we're going to sketch a graph of the function f of x equals the square root of x. Now this is one of our parent functions. So we know that this is, remember, this top half of a sideways parabola. And we could plug in points to remember what that is. When x equals 1, the square root of 1 is 1. When x equals 2, the square root of 2 is not a very nice number. The square root of 3 is not a very nice number, but the square root of 4 is an easy one. That one's 2. So our pattern is just, 1, 1, 4, 2. So that's the square root of x. And then it says, find the inverse of the square root of x. So we're going to switch x and y. So instead of y equals root x, we're going to have x equals root y. And then y needs to be all by itself. Nothing needs to be going on with y. So we need to go ahead and square both sides. So x squared equals y. But is that truly the inverse of this function? Like if I graphed y equals x squared, which is a full parabola, and I took the inverse of it, would it look like that purple thing? It wouldn't, right? Because they are not truly inverses of each other, because we're only taking half of the parabola, correct? We're only taking half of it. So we have to decide which half are we taking. Well, we're taking the one where x is greater than 0, because our original function has a domain. X has to be greater than or equal to 0, and then a range that y is greater than or equal to 0. And when we have inverse functions, their domains and ranges switch. So our domain is still x is greater than or equal to 0, and our range is y is greater than or equal to 0. So for this one, we're going to say that our function is x squared equals y with this domain restriction. Okay, now we're going to sketch the graph on the same coordinate plane. So this is a regular parabola, but the other, just the right half of it. Just going to go through that point right there. I'm going to 2, 4, right there. Okay, so there's the inverse functions of each other. So now what we have to do is differentiate both of these functions. So when we differentiate, let's do f of x first. So f of x was y equals the square root of x. So y prime would be 1/2 x to the negative 1/2. Okay, and now if I'm going to differentiate the inverse, so I could write it like this, the inverse, the derivative of the inverse, equals, let's see, so that would be 2x, and that's it. So find the slope of the graph at f of x at 4, and the slope of the graph at f of the inverse of f at 2, 4. So let's figure out when x equals 4, what is the slope of this graph? So we have y prime equals 1/2 4 to the negative 1/2. Show up, there we go. And that equals 1/2 times 1 over the square root of 4, which is 1/4. Okay, so the slope at 4 is 1/4. Okay, now what is the slope of the inverse at 2/4? Well, that would be m equals 2 times 2, which is 4. Okay, so the slope of the inverse at the other point is 4. Okay, so what conclusions can you make about the slopes? Well, they're reciprocals, right? They're reciprocals. They're not opposite reciprocals, they're just reciprocals. So, I mean, I guess it makes a little bit of sense because the slope is change in y over change in x. And when we switch x and y, then we get change in x over change in y. So that makes sense that our slopes would be reciprocals. So let's practice this and see if we can find the reciprocals. So basically, this is kind of the actual definition stuff with inverses. If you have some point, a, b, on a function, then on the inverse function you have a point ba, because we know that's the definition of the inverse, and the derivative at that new point is the reciprocal of the derivative at the old point. That's not too hard. You're going to see it this way a little more often. So if f and g are inverse functions, then the derivative of g is equal to 1 over the derivative of the composite of f and g. So just remember that they have reciprocal slopes at image points, which are basically the points that are reflected across the y equals x. So let's take a look at how this actually works. So we have two functions, f and g, and when they gave us some information about f and some information about g, and g is the inverse of f. So we know that there are some points on f, right? So let's just go ahead and fill those out. We know that this point -1, 1 is on f. We know that the point 0, 2 is on f, and we know that the point 1, 5 is also on f. So what do we know about the points on g? Well, they would be 1, -1, 2, 0, and 5, 1, because they're not reciprocals, they're image points, so they just flip x and y. Now, what do we know about the slope of the first point? Well, we know the slope of the first point, it tells us right here, is 3/2. The slope of the second point is 2, and the slope of the third point is 1/2. So, what do we know about the slopes of the inverse function? Well, that would be 2/3, that would be 1/2, and that would be 2. Okay, so we just fill out the table. Sometimes it's not going to give you a table, you just have to make your own table, but that's not too hard, right? So then it says, from the given information, find everything that you can. Okay. And it says, make a table, but guess what? I already made one for you. That's so nice. Okay, so what is g prime of 1? So let's think, what does it mean? G prime of 1 means what's the slope when x equals 1 in the function g, right? What's the slope when x equals 1? It's 2/3. What's the slope when x equals 2? It's 1/2. What's the slope when x equals 3? We don't have that point, so we don't know. What's the slope when x equals 0? That's also unknown. And what's the slope when x equals 5? It's 2. All right, so that's it for this video. We'll have one more video.